Have you ever noticed how your car side mirror makes vehicles look smaller, but your bathroom mirror can make your face look bigger? That is not magic, that is physics. Today we are diving deep into the fascinating world of concave and convex mirrors. These two curved mirrors may look simple, but they completely change how light behaves. By the end of this video, you will understand how images are formed, why size changes, and why these mirrors are used in cars, headlights, and solar devices. Let's break it down. First, we need to understand what a spherical mirror is. A spherical mirror is a mirror that forms part of a sphere. Instead of being flat like a regular mirror, it is curved. There are two main types, concave and convex. The difference depends on which side reflects light. If the reflecting surface curves inward like the inside of a bowl, it is called a concave mirror. If it bulges outward like the back of a spoon, it is called a convex mirror. This small difference in shape completely changes how light behaves. Let's start with the concave mirror. A concave mirror curves inward and is often called a converging mirror. Why converging? Because when parallel light rays hit its surface, they reflect and meet at a single point called the focus. This focusing ability makes concave mirrors powerful. They can concentrate light energy into one strong beam. That is why concave mirrors are used in car headlights, flashlights, and even solar cookers. They gather light and direct it efficiently. Now here is where things get interesting. The image formed by a concave mirror depends entirely on where the object is placed. If the object is far from the mirror, beyond the focus, the image formed is real and inverted. That means it appears upside down. But if the object is placed between the focus and the mirror, the image becomes virtual, upright, and magnified. This is why they are makeup mirrors. Real images and virtual images are important concepts in optics. A real image is formed when light rays actually meet after reflection. These images can be captured on a screen. A virtual image, however, is formed when rays appear to meet but do not actually cross. Concave mirrors are special because they can produce both types of images. This flexibility makes them unique compared to convex mirrors. Now let's move to the convex mirror. A convex mirror curves outward and is known as a diverging mirror. Instead of bringing light rays together, it spreads them apart. When parallel rays hit, they reflect outward as if coming from a point behind. This point is called the virtual focus. Unlike concave mirrors, convex mirrors never form real images. They are always virtual and smaller. This constant shrinking effect is exactly why convex mirrors are used in vehicles. Car-side mirrors provide a wider field of view. Because the image is smaller, objects may appear farther away. That is why side mirrors include the warning, "Objects are closer than they appear." Convex mirrors are also widely used in security systems. You often see them in shops, parking garages, and blind road corners. Their outward curve allows them to cover a large area. Even though the images are smaller, they help prevent accidents and theft. To truly understand these mirrors, we must discuss the law of reflection. The angle of incidence is equal to the angle of reflection. This rule applies to all mirrors. However, in curved mirrors, the direction of the surface changes at every point. Ray diagrams help us understand. In concave mirror ray diagrams, one ray travels parallel to the axis and reflects through the focus. Where these intersect, the image forms. If they physically meet, the image is real. If only their extensions meet, it's virtual. These rules allow us to predict image position and size accurately. For convex mirrors, the process is slightly different. A ray parallel reflects outward as if it came from the focus behind. The reflected rays never meet in front. Magnification is another key concept. It tells us how large or small an image appears compared to the object. In concave mirrors, it can be positive or negative. There is also the mirror formula, 1 over focal length equals 1 over image distance plus 1 over object distance. Scientists use this for exact calculations. Concave mirrors play an important role in medical tools. Dentists use them to see enlarged images. Scientists use them in telescopes. Solar furnaces use large concave mirrors to focus sunlight and generate extreme heat. Their ability to concentrate energy is incredible. Convex mirrors focus more on safety. They prevent blind spot accidents and allow drivers to monitor traffic efficiently. The outward curve is for awareness. When we compare both, the difference is clear. Concave mirrors converge and magnify. Convex mirrors diverge and expand your vision. By understanding these mirrors, you are learning how light interacts with surfaces and how science shapes daily life around you. Next time you look into a mirror, remember you're witnessing physics in action. Science is everywhere. Thanks for watching and stay curious.